Hi guys, so the next topic on chapter 22 is looking at alcohol. So these are our final tetrahedral carbon compounds. So alcohols are a homologous series of compounds. You can recognize them from the OH group that they'll have at the end of them. This is called a hydroxyl group. I have a little box here to kind of help you to remember that. The hydroxide ion is OH minus. When it's bonded to an organic compound, it's called a hydroxyl group. And that hydroxyl group is known as a functional group. And a functional group is an atom or group of atoms which is responsible for the characteristic properties of an organic compound or a series of organic compounds. So it's this hydroxyl group, the OH, that gives alcohols their characteristic properties that we'll see a little later on. This is just one of many functional groups that we will see, and you do need to recognize them from each other. So looking straight away, if you saw anything that looked like any of these, you should recognize them as an alcohol straight away just by the OH group at the end of the way it's written out there. The naming, we don't necessarily need rules because you name them exactly like an alkane, but instead of an E at the end calling it methane, you replace the E with OL. So all alcohols, the ending of the word or the ending of their name is ol. So ethanol is ethane, where one of the hydrogens has been replaced with the hydroxyl group. Propan-1-ol and propan-2-ol are propane, where for 1-ol, the OH group, the hydroxyl group, is on the first carbon. Propan-2-ol, the hydroxyl group is on the second carbon in the chain. So we'll just have a look at some of those. Methanol, the OH group, is on the carbon. It's replaced a hydrogen group. Now it's important to just look at the way that's drawn there, the bonding of it. So we've got carbon forming one bond to the oxygen, and the oxygen is then bonded to the hydrogen. Same for ethanol, we've got ethane, where one of the hydrogens has been removed and it's been replaced with the hydroxyl group, carbon bonded to oxygen, which is then bonded to hydrogen. And that's why we write it as OH, because the oxygen is bonded to the carbon and the hydrogen is bonded to the oxygen. Looking at propan-1-ol and propan-2-ol, the difference here is that in propan-1-ol, the hydroxyl group is on the first carbon, and propan-2-ol, it's on the second carbon here. Another thing to note about how it's written out, you can draw out the bonding, show the bonding like this, or you can choose to not show the bonding between the O and the H and just write OH on there. It makes it a little bit tidier, so people do that often. The thing you need to be careful with here is that the carbon that bond from the carbon has to be going to the oxygen. If that carbon is bonded to the hydrogen, you could lose marks there. So just make sure that when you're drawing it out, you're not sloppy, that you do it carefully so that the carbon and oxygen are clearly bonded, and then the hydrogen can just go next to the oxygen. Butan-1-ol and butan-2-ol here. Same thing again, 1-ol means the OH, the hydroxyl group, is on the first carbon. Butan-2-ol, the hydroxyl group, is on the second carbon. And you can see that's written out there, and I didn't mention that about propan-2-ol actually. The way that the condensed structural formula is written, we're using brackets there so as not to confuse this H with one that's bonded to a carbon. Classification of alcohols then. So we have primary and secondary alcohols that we're going to look at, and this is because depending on where the alcohol group is, where the hydroxyl group is, the alcohols can have slightly varied properties. So a primary alcohol contains one carbon atom directly attached to the carbon that contains the hydroxyl group. So work backwards here, find the hydroxyl group, it's over here. Look at the carbon that contains it, so I've circled that in yellow here. So this is the carbon which contains the hydroxyl group. And then you're looking at the bonding, how many carbons is that carbon bonded to? And here in pink you can see that there's only one carbon bonded to that, the other bonds are to hydrogens. So that makes it a primary alcohol, primary meaning one or first, so the carbon that's attached to the hydroxyl group is only bonded to one other carbon. A secondary alcohol then is when the carbon with the hydroxyl group on it contains bonds to two carbons. So again, our hydroxyl group is here. Look at the carbon that it's attached to, and how many bonds to other carbon atoms does that have? There's two bonds here shown in pink, so it's bonded to two other carbons, so that makes it a secondary alcohol. Methanol then, methanol, you need to know some of its properties. It's toxic, can cause all of these horrible symptoms. It's added to industrial alcohol to prevent people from drinking it, and this mixture is called methylated spirits. You might have heard of that before. Methanol acts as a denaturing agent. It renders a substance unfit for purpose without destroying the usefulness or applications of the substance. So it's added to industrial alcohol. The industrial alcohol retains its usefulness and its applications, but it's unfit for purpose as an alcohol to drink. A purple dye is often added as a warning. And up on top here, just a couple of different ways you could draw out the structure of methanol. Next, we've got ethanol. It's produced by fermentation. Fruits provide the sugar, which is C6H12O6 here, and yeast may need to be added as well to get the reaction going. The enzyme zymase in yeast catalyzes the reaction. So you may need that catalyst in there. And what we get here is ethanol, C2H5OH, and carbon dioxide being produced. Some uses of ethanol: it's used as in alcoholic drinks, can be used as a fuel, and it can also be used as a solvent. It's a very useful solvent because it dissolves both polar and non-polar solutes. Physical properties of alcohols: they're all liquids and they all at room temperature. So anytime we're talking about physical state, that's going to be at room temperature. Boiling points are much higher than the corresponding alkanes. The reason for that is that the OH group is polar, and so that allows the alcohol molecules in a solution to form hydrogen bonds between them. So this is your hydrogen bond, that's going to take more energy to break those molecules apart. You can see here the number of carbon atoms as it increases. The boiling point increases, similar to the alkanes in red, but the alcohols, so if this was, I'm not sure if this is methane, but if this was methane and this was methanol, you can see that the boiling point of methanol is much, much higher. Solubility then of alcohol. So methanol is not very soluble in cyclohexane because methanol is mostly polar because of that OH group. There's only one carbon in there, so the OH group is polar, and so it won't dissolve very readily in cyclohexane, which is non-polar. In contrast, it's completely soluble in water because both of them are polar substances. As the alcohol molecule gets bigger, the polar part becomes less significant. So the alcohol becomes less soluble in water and more soluble in cyclohexane. So what that's saying is, as your carbon chain, which is non-polar, gets longer and longer, that starts to take over and cancel out the polar OH group. And so what happens then when we get up to butanol, so 4 carbons, butanol is soluble in cyclohexane because it's got a longer non-polar carbon chain, and it's not very soluble in water because water is polar, and now the polar OH group is less significant because the non-polar part of the molecule is much bigger. Just to compare it with water, both have OH groups. Alcohols have a non-polar part, which water doesn't have. They can both form hydrogen bonds between their molecules, and water is more polar and has a greater capacity to form hydrogen bonds, and so has higher boiling points than methanol or ethanol. So there's 2 hydrogens on water. It's much more polar, can form hydrogen bonds more easily and stronger, so the boiling point is going to be higher. Here are your questions to finish after this video. So I'd hope to receive these from you over on Microsoft Teams within the next 10 minutes.